All right, welcome. Today, we're jumping right into a huge topic in networking, DMVPN, or Dynamic Multipoint VPN. We're going to start at the very beginning and really demystify its foundational first step, NHRP Phase 1. This is all about understanding how these massive, secure networks are built from the ground up.
So, let's set the stage. Imagine you're the one tasked with a huge project, connecting hundreds of remote offices back to your main headquarters. How in the world do you do that securely and in a way that can actually scale? Well, this is the exact problem DMVPN was born to solve. And its most basic foundational answer is what we call Phase 1.
And to really get our heads around this, here's our game plan. We're going to start with the big picture of what Phase 1 even is. Then, we'll dig into the hard and fast rules of its architecture. After that, we'll actually trace a single packet on its journey, figure out the role of a key protocol called NHRP, and finally, we'll nail down the core limitation that really defines Phase 1.
Okay, let's start with that big picture. So, what exactly is Phase 1? Well, at its heart, it's the simplest, most straightforward version of DMVPN you can get. It's built on a really classic network design that you've probably seen before, the hub and spoke model.
You know, the best way to picture this is with an analogy. Just think about how airlines work. Your main headquarters, that's your central hub, like a giant airport, maybe O'Hare or Heathrow. All your remote offices are the smaller regional airports. Now, here's the deal in Phase 1. If you want to fly from one of those small cities to another, you have to connect through that main hub. There are absolutely no direct flights between the smaller airports. It's just not allowed.
And that whole no direct flights thing, it isn't just a suggestion. In Phase 1, it's basically a law of physics for the network. There are these very specific, non-negotiable rules that every single device has to follow, no exceptions.
The principles here are incredibly clear-cut. First, it is a strict hub-and-spoke design. Second, and this is the big one, all traffic between those remote sites, the spokes, must go through the central hub. Spokes are totally forbidden from talking to each other directly. And this whole setup is made possible by a few key pieces of tech working together. GRE for the tunnels, IPsec to keep them secure, and that protocol we mentioned, NHRP, in its most basic form.
So yeah, it's really this simple. If Spoke A needs to send something to Spoke B, the path is always Spoke A to the hub and then over to Spoke B. That direct path from spoke to spoke, not an option. It's off limits. This is probably the single most important rule to remember about Phase 1. So knowing that rule, let's make this way more concrete. We're going to follow a single packet of data on its journey from one remote office to another, step by step. We're going to see exactly how this whole hub and spoke thing works in the real world.
You know, the journey actually starts before any data is even sent. The first thing that has to happen is each spoke has to build a permanent, secure tunnel directly to the hub. Think of it like its own private, dedicated highway. So Spoke A builds its highway to the hub, and Spoke B builds its own separate highway to the hub. These are static, they're pre-configured, and they're pretty much always on. Okay, time to actually send some data. A user over at Spoke A wants to reach a server at Spoke B, so their computer creates a packet. Spoke A's router sees this packet and basically says, well, I only know one way out of here, and that's its tunnel to the hub. So it wraps the packet up, that's a process we call encapsulation, and sends it down its private highway, heading straight for the hub. And here's where the hub really earns its keep. It gets that packet from Spoke A and unwraps it. It takes a look at the destination and says, aha, this needs to go to Spoke B. Then it rewraps the packet, but this time it addresses it for Spoke B's tunnel. Finally, it sends that newly wrapped packet down the correct highway to its final destination. The hub is literally acting as a central mail sorting facility for the entire network. So, we've thrown this acronym around a few times, NHRP. The Next Hop Resolution Protocol. Its role in Phase 1 is super specific, and honestly, it's often misunderstood. So let's clear up what it actually does, and maybe even more importantly, what it doesn't do. In Phase 1, you can basically think of NHRP as a really simple address book that's kept by the hub. When a spoke router first turns on, it just registers itself. It sends a message saying, hey hub, my private tunnel address is X, and if you need to reach me, my public internet address is Y. That's it. The hub just keeps this static list, mapping one to the other. Now this is absolutely crucial to understand. In Phase 1, NHRP is not used by the spokes to dynamically find each other. It's not some kind of peer-to-peer directory service for building direct tunnels on the fly.
Its one and only job is that initial static registration with the hub. All the cool dynamic stuff that actually gives DMVPN its name, yeah, that's all being saved for the later phases.
Okay, so let's pull all this together and zoom back out for the main takeaway. Because really, understanding Phase 1 is all about understanding its main purpose and, because of that, its core limitation.
Here's the bottom line. In DMVPN Phase 1, the hub isn't just important, it is the mandatory, non-negotiable middleman for everything. It's the traffic cop, it's the mail sorter, it's the central switchboard, all rolled into one. Every single packet going between any two remote sites has to check in with the hub first. No way around it.
Look, if you remember only one single thing from this entire explainer, make it this golden rule. In Phase 1, all traffic between spokes goes through the hub. That's it. That is the single defining characteristic that separates it from all the more advanced phases to come.
And, that leads us to a final, really critical question. Sure, this design is simple, it's predictable, but what's the cost? What happens to your network's performance and latency when every single conversation has to take that extra hop through the hub? And, more importantly, how do we fix that bottleneck? Well, the answers to those questions are exactly what Phases 2 and 3 are all about.